Today we're going to be talking about complex numbers and quadratic equations. Now first, let's talk about what the definition of a complex number is. We're going to talk about what is the definition of an imaginary unit. Well, an imaginary unit would be trying to take the square root of a negative number. So if you notice, the square root of -1, we're actually going to start calling that I. It stands for imaginary. So we can take the square root of a negative number. It's just going to be an imaginary. And so if you look, a complex number is complex, meaning it's made up of more than one thing. It's got a real part to it, meaning that would be just a number, and then an imaginary part to it. An example of a complex number would be -4 plus 2i. Notice we've got the real part, which is just the number -4, and then we've got the imaginary part, which is the 2i. Put together, that is a complex number. Now take notice of the order that we put it in. We always put the real part first and then the imaginary part. So as we go down and we work on our numbers, we're going to make sure that we order it in a plus bi form. That is standard form for a complex number. So if you hear me say standard form for a complex number, that is what I mean. So first we're going to just talk about how do we simplify numbers using the imaginary unit. So take -√18, for instance. Now before, I would say you get to this point and you say what? You can't take the square root of a negative number. And so we would just say no solution and we would move on. But now we're going to talk about breaking that down. First thing you want to do is you want to pull out the negative so that it becomes real again. Now when I pull out the negative, that is like saying -1 times the square root of 18. And if we go back up, we know -1, the negative square root of 1, we can write that as I. So what I'm going to do is when I pull out the negative, it's going to be I square root of 18. Now remember, back to our radical rules, we can break 18 down. So think about what times what gives you 18, that one of those is a perfect square. -9 times 2. Because we can take the square root of 9, and that's 3. So we're going to simplify this down. I'm going to come over here and write it. 3i square root of 2. Another way you could look at this is to not worry about the negative until the very end. So we could have come over here and said, okay, I know I have negative square root of 18. I'm going to pretend that I just have a square root of 18. And you could have followed the regular rules of breaking down the square root of 18. And so you know that's 3 squared roots of 2. And then you simply add in the I at the end. And so that's another way to look at it. If following this pattern is confusing, you can just pretend that it's positive, break it down like you normally would, and then add the I in at the very end. So let's take a look at the square root of -12. Again, I'm going to start by pulling out the negative and just putting it as an I. And then from there, I can break down the square root of 12. I have square root of 4 times square root of 3. I can take the square root of 4, and that's going to be 2. So I'm going to wind up with 2i square root of 3. So you kind of have to dust off those radical rules that we talked about at the very beginning of the semester. Now this one, if I were to have a positive square root of 25, if this were just to say square root of 25, that has a perfect square, it's 5. So here, what I'm going to say is that the negative square root of 25 is not just 5, but it's 5i. And that's my solution. So sometimes you're going to come across negative square roots where it actually works out. So another example of this would be, negative square root of 36. So I know negative square root of 36 I can't do, but I can take the square root of 36, and that's 6. So I know this is going to be 6i. Let's come down to an example that we're not going to be able to simplify. So again, I'm going to start by pulling out the I. And that's what I'm left with. Now, if I'm trying to find the factors of 7 that break down, it's just 1 and 7. The 1 or 7 have a perfect square root. So we're just going to leave it like that. That's as simple as I can make it. And now we're going to start talking about adding and subtracting complex numbers. So now we're going to add, subtract, multiply, and divide complex numbers. Now, when you do this, treat I like if it's like an X. Okay, so it's almost like it's like a variable. And so we're going to treat it like if we can only combine the things that are the same. So here I can combine the terms that have I in them, and I can combine the numbers. So when I do that, 4 plus negative 4 is 0. And negative 3 plus positive 3i is 0. Now in this one, it actually zeroed out. So our answer is 0. On part B, when you have a negative, you have to distribute it to everything behind it. So I'm going to come over here and I'm going to rewrite 5 minus 3i plus 2 minus 4i. And so again, you're going to combine the numbers and combine the imaginaries. When I combine the numbers, 5 plus 2 is 7. And when I combine the imaginaries, negative 3i minus 4i is negative 7i. And that is my final answer. Now you always want to make sure that it's an a plus bi form. So if your I comes first, you need to switch it and make sure that it is put in a plus bi form. If it's not, you're going to lose points on your homework, your quizzes, and your tests. So make sure you get into the habit now of putting them in the correct order. I'm going to do another subtraction problem. So again, make sure that you distribute that negative through. So 8 plus 6i minus 8 plus 6i. Again, I'm going to combine my numbers. So 8 minus 8 is 0. Now you can write 0 or you don't have to. It's not necessary. And then I'm going to combine my imaginaries. So 6i plus 6i is 12i. And that is your solution. Sometimes complex numbers only have the number. So it could be that you only wind up with a number, and sometimes you only wind up with an imaginary. And that's okay. That doesn't mean that you did it wrong. That just means that it's missing part of the complex number. Now we're going to work on finding the product. Product means multiplying. So when you see parentheses with no sign in between, some of you guys get mixed up between when you know to subtract or add and when you multiply. Now notice right here in between my parentheses I have a minus sign, or on this one a plus sign. Okay, notice here there's no sign, a plus or a minus in between. So that is what tells me that I need to multiply. So pay very careful attention when you're working through that you're not adding instead of multiplying, or that you're not multiplying when you should have added. Pay very close attention. On this one, all I'm going to do is distribute through. So I'm going to have negative 15i plus 6i squared. Now, something that we didn't cover at the beginning is what happens when you have an I squared. So let's come back up here and let's take a look. If I square both sides, so in other words, when I square that, it's going to cancel out the square root. What does I squared equal? It's going to equal -1. And so often when we are working through complex numbers, we will always change I into -1. And what that does is that changes it from an imaginary number back to a real number. We're going to talk about, on dividing complex numbers, why that's important. But first, so basically when I have changed that I squared into a -1, what I've done is I've said now I'm multiplying 6 times -1. 6 times -1 is -6. Now, this would be my answer, but what is the problem here? We have a problem, and that's that it's not in A plus BI form. So we always want to make sure that we have it in A plus BI form. Now, if I'm putting this in A plus BI form, make sure you take the signs with the number. So I'm going to write that as -6 minus 15i. And there is your final answer. Now, on part B, notice we have 2 terms by 2 terms. That's a FOIL problem. And we're going to FOIL it together just like we do any other multiplication problem. So I'm going to start and just say, you could also just call that, instead of FOIL, distributing. So you're just going to make sure you distribute everything in the first parenthesis to everything in the second parenthesis. So this gives me -4. This gives me -8i. This gives me -3i. And this gives me -6i squared. Now, before we combine like terms, I've got to change I squared into -1. So when I do that, that is going to create this to be a +6. Let me recopy the rest of the problem. And now we can combine like terms. So I'm going to combine my numbers. -4 plus 6 is 2. And then I'm going to combine my imaginaries. -8i minus 3i is -11i. Make sure, is this in A plus BI form? And it is, so we're done. On part C, it's a little tricky because that square means that there's 2 plus 7i's. So what I'm going to do is I'm going to come and I'm going to write both of them side by side. Don't make the common mistake of just squaring this and being done. That is not going to give you the correct answer because you're missing the middle terms when you do that. We have to distribute, multiply, FOIL. So that's what I'm going to do. 2 times 2 is 4. 2 times 7i plus 14i. 7i times 2 plus 14i. 7i times 7i. Well, first off, 7 times 7 is 49, and I times I is I squared. Now again, before we start simplifying, change I squared into -1. When I do that, that causes this to become -49. 4 plus 14i plus 14i. Now I can combine like terms. So I'm going to combine my numbers. 4 minus 49 is -45. And 14 and 14i make positive 28i. And we're done. Make sure that it's an A plus BI form. A plus BI. And it is. So we can be done with the problem. Now we're going to talk about dividing complex numbers. This is kind of a different ballgame because if you remember, we don't like to have irrational things in the bottom. So if you remember back when we did radicals, if I had a square root in the bottom, I had to do something called rationalizing the denominator to get it out of the bottom and create a rational number on the bottom again. So what I did was I went from an irrational number, a square root, back to a rational number by doing that, rationalizing the denominator. We're going to do the same thing here because I is not rational. So what we have to do is we have to get any I that we see out of the bottom. He cannot be in the bottom. We do that by rationalizing the denominator. So if you notice here, I have a 3i on the bottom. Now the 3 is okay. He's not irrational. It's the I that's the problem. So on here, I'm going to just multiply the top and the bottom by I. When I do that, I get 9i plus 12i squared on the top, and I get 3i squared on the bottom. Because remember, I squared turns into -1. So I'm going to change all of my I squares into -1s. Now let's rewrite what we have. So I have 9i minus 12 on the top, and I've got -3 on the bottom. So have I accomplished what I set out to do by making my bottom rational? It went from 3i to -3. And I did. We've got one more step because what form does it need to be in? It needs to be in A plus BI form. So first thing I'm going to do is I'm just going to take -3 and I'm going to divide it into each. I can do that because it's only one thing on the bottom. So when I do that, I get 9 divided by -3, which is -3i, and I get -12 divided by -3 plus 4. Is this an A plus BI form? It's not, so what I need to do is I need to switch it. So I'm just going to switch these two, flip-flop them. 4 minus 3i. That is your final answer. So on part B, we're going to do the same thing. The 6 is not the problem on the bottom. It is the imaginary. It's the I. So I'm going to multiply the top and the bottom by I to try to get rid of it. On the top, when I do that, because that's basically just like distributing the I through, I get 4i minus I squared. And on the bottom, I get 6i squared. Now what I'm going to do is go through and I'm going to change all of my i's to negative ones. So that's going to leave me with 4i plus 1, because this negative and this negative is going to make a positive, over negative 6. And then the last step is get it into a plus bi form. So I'm going to do 4 divided by negative 6, which reduces to negative 2/3 I. And then 1 divided by negative 6, which is negative 1/6. Leave these as fractions, not as decimals, unless it tells you that you can leave it as a decimal. Am I done? Have I left it in a plus bi form? I have not, so I've got to switch them. Play switcheroo. Negative 1/6 minus 2/3 I, and that will be your final answer. Now we get to the ones where there's a complex number on the bottom. See, we've got 3, which is a real number, plus the 4i. So all together, that makes a complex number. You have to do this a little bit differently because I can't just multiply by I. It's not going to create a rational denominator. But what I can do is I can multiply by what's called the conjugate. Conjugates are opposites of each other. So if my bottom is 3 plus 4i, then what I can do is I can multiply by 3 minus 4i. What I do to the bottom, you have to do to the top. So what I've done is I've created opposites of each other to where my middle terms, when I'm multiplying these two together, foiling, are going to cancel out. So all you have to do is multiply your first terms together, so 3 times 3, which is 9, and your last terms together. So 4i times negative 4i, negative 16i squared. But we also have to FOIL the top together. And those aren't going to cancel out. So we've got to do the whole thing. So 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2i times 3 is negative 6i. Negative 2i times negative 4i is positive 8i squared. I've got to combine like terms, but first I'm going to go ahead and I'm going to change my I squares into negative ones and go from there. So that's going to give me 15 minus 20i minus 6i minus 8 over 9 plus 16. That negative times the negative is going to make a positive. So now I'm going to combine like terms. My 15 and my negative 8, 7. And my negative 20i, negative 6i is negative 26i. All over 25. We're almost done. We still have to break it apart into a plus bi form. So split it. 7 over 25 minus 26 over 25i. And that's an a plus bi form, and we're done. That takes care of dividing complex numbers. Nope, we still have one more. We got another one that has a conjugate. So same thing, I'm going to multiply by 8 minus 7i, which is the conjugate. So what I do to the bottom, I have to do to the top. So on the bottom, we created it to where we only multiply our first and our last terms together. So that's going to be 64 minus 49i squared. And on the top, I'm actually going to FOIL those together. 8 times 8, 64. 8 times negative 7i, negative 56i. 8 times negative 7i, negative 56i. Negative 7i times negative 7i is positive 49i squared. Next step, change your I squares to negative ones. And then combine like terms. So I've got 64 minus 56i minus 56i minus 49 all over, that's going to be 64 plus 49. So if you notice, changing the I squares to negative 1 is really just changing the sign on that number. So I'm going to combine like terms. And when I do that, I get 15 minus 112i over 113. So then our last step will be to split it into a plus bi form. So that's going to be 15 over 113 minus 112i over 113. And there's your final answer. So now we're going to talk about factoring using complex conjugates. Before, when we talked about factoring, we could factor a difference of squares, but I've always told you there's no such thing as a sum of squares. The reason is there's no such thing as a sum of squares in the real world, but there is such a thing as sum of squares in the imaginary world. And so let me show you. If I just asked you factor that, first thing you would do is you would take out what they have in common. So they have a 2 in common. You could divide 2 and 32 by 2. So do that, and that leaves you with x squared plus 16. Now, at this point, I've always told you you can't take that any further. But now that we are talking about imaginary numbers, you can. Remember, back when we worked on factoring, if I gave you x squared minus 16, that is a difference of squares, which means everything has a square root, and we can break it down to x minus 4, x plus 4. So if I can break down x squared minus 16 into x minus 4 and x plus 4, what do you think I can break x squared plus 16 into? I'm going to be able to break that into x plus 4i and x minus 4i, since we're working with imaginaries. So there technically is no such thing as a sum of squares. But in the imaginary world, we can do that. So let's do part B. Same thing. I'm going to factor out what I can to begin with. They both have a 5 in common. So when I take out the 5, I am left with x squared plus 4. Now, come over here and always say, go ahead and write out the difference of squares so that you can see what it should be. I know that x squared minus 4 is going to break down to x minus 2 and x plus 2. So go ahead, now that I know that this breaks down to x minus 2 and x plus 2, I know that in the imaginary world this is going to be x plus 2i, x minus 2i. And so we've got one more. X squared plus 81. So first look and see, can you take anything out that they might have in common? They don't have anything in common. Now, I know that x squared minus 81 is a difference of squares, and will break down to x minus 9 and x plus 9. So what you're going to do is you're going to come over here and write it as x minus 9i and x plus 9i. And there you have it. Factoring imaginaries. Now, on these equations, you're going to use quadratic formula, which is what we worked on last time. So you're going to identify what is A, what is B, what is C. We're going to plug it in. So negative 3 plus or minus the square root of negative 3 squared minus 4 times A times C, all over 2A. So when we simplify that down, remember I talked about how you start with everything underneath. If you can plug this in exactly as you see it into your calculator. So go ahead and plug that in, and you get 3 plus or minus negative 31. So when you plug all of that into your calculator, you get negative 31 all over 4. Now before, when we would work this through at this point, because of this negative, we would say there's no solution. Technically that's right, but we do have imaginary solutions. So now we're going to break it down further. And this one, all we're going to be able to do is pull out the I, pull out that negative, because we cannot break 31 down any further. And so that is going to be our answer. Now notice, it's nice because this is an a plus bi form. 3/4 plus or minus I squared of 31 over 4. We're going to do it again just to practice. So again, start by identifying what is A, what is B, what is C. Remember, before we do that, if it's not solved for 0, if we don't have everything on one side, you've got to scoot it over and make sure that everything is on one side before you start. So I'm going to plug it in. A negative 1 plus or minus the square root of b squared, so negative 1 squared minus 4 times A times C, all over 2A. So that's going to give me 1 plus or minus. Now if you plug everything underneath exactly as you see it into your calculator, you will get negative 23. And so from there we're going to say negative 23. We're going to work on breaking that down. 23 doesn't simplify any further. We can't take any perfect squares out. The only thing that we're going to be able to do is pull the I out. So 1 plus or minus I square root of 23 over 6. If you leave a negative under a square root in your answers, from now on it's going to be wrong. You have to pull it out and make it an imaginary. So let's do one more. My A is 1, my B is negative 4, my C is 5. Negative and negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 5, all over 2 times 1. Again, plug everything into your calculator underneath that you see here, and that is going to give us the square root of negative 4 over 2. Now, we can do the square root of 4. It's 2. But because of that negative underneath, it's going to become 2i. So I'm going to change this whole thing here into 2i, and we're going to simplify it further. 4 plus or minus 2i over 2. So if you get one that will break down completely, then you'll need to take this further. Now remember what we talked about the last time. We have the magic triangle. If we can divide all three of these numbers by the same thing, we can reduce it. So notice, I can divide all three of these numbers by 2. So that's exactly what I'm going to do. And that's going to give me 2 plus or minus 1i over 1. Now, do you have to put the ones? You don't have to put the ones. So in this case, it's just going to simplify to 2 plus or minus I. And that's it. You've taken it as far as it'll go. And that takes care of complex numbers.